So we're looking at the last section in our chapter of the textbook on limits and derivatives, formal definition of derivatives. We're looking at now, given a graph of our function f of x, we should be able to give a general sketch of what the derivative function would look like. And so remember, derivative is the rate of change of what's happening at some x value. And so if we want to graph f prime of x, what we're looking at, our points are going to be when x is a, our y value is going to be, what is that slope? What is that instantaneous rate of change? What is that derivative when x is a? And so usually when I'm going to graph this, the first thing I look at are there any lines on my graph? Because if there's any lines on the graph, those are a constant rate of change. And so looking at this, I see from negative infinity to x equals -2, I had this horizontal line. And so I think to myself, what do I know about the slope of a horizontal line? Well, I know that the slope of a horizontal line, the slope, or f prime of x in this case, is equal to 0. So for my points on f prime of x, I know, well, when x is like a -1,000, I'm coming in from negative infinity, that my derivative at f prime of -1,000, that slope is 0. If I looked at coming into -4, that slope at this point, it's horizontal, is still 0. When I come into -1, my slope is still 0. And then as I'm getting to -2, this is where I have a sharp corner. And remember, sharp corners on our graph, the slope does not exist, or the slope, or it's not differentiable there. So sharp corners, there's a couple places where we have sharp corners. So at x equals -2, x equals 0, and x equals 1. So sharp corners, recall the derivative does not exist. So the values where it doesn't exist, we're going to put open circles at those points. Okay, so again, we're coming in from negative infinity to x equals -2. And we saw that the value, we had a y value of 0. X equals -2, it was not differentiable, so I'm going to put a circle there, but my y values for the derivative function were always 0 from negative infinity until we get to -2. So now, and let's look at what's going on from this piece where it's going down. It's decreasing from -2 to 0, the interval notation. And so we're coming down here. And this is a line. So again, I know my slope of that line is always going to be the same. So I need to figure out, what is this slope? So let's find the slope of f of x. Or another way to say that, f prime of x on the interval from x equals -2 to 0. Well, if you can't see, we know it's rise over run. And so in this case, notice if we run over 1, we're going down 1. So we're decreasing by 1. So -1, and we're going over 1 positive, over 1. Let's just make sure that that's the same case, right? I'm going over 1 and I decrease 1. So my slope on that interval from -2 to 0, that slope is -1. So I just want you to be careful because this right here kind of looks like this right here. But this is talking about X values, where over here I was talking about points. Okay, so starting at X equals -2, I have a Y value of -1. X equals -2, I have a Y value of -1. Except that it's undefined at X equals -2. So I'm going to put an open circle down here. And then we knew it was decreasing and that Y value until I get to 0, and it's undefined there. So I'm going to put a circle. It was always -1. Now I'm going to go to the next piece of the graph where I see that it's increasing. It's increasing from X equals 0 to X equals 1. So I need to figure out what is the slope. So find the derivative of f of x on the interval when x is 0 to x is 1. Or another way to write this, I could say this is the same thing as saying 0 is less than x, which is less than 1. So my slope there, I'm just going to call it m. I'm going up. I'm rising 1 as I run over 1. So 1 over 1, which is 1. So I know all the x values between x equals 0 and x equals 1. My y value is going to be what my slope was, which is 1. So at x equals 0, I have 1, although it's undefined because it's a sharp corner. At x equals 1/2, that's in between 0 and 1, my y value, that slope is still 1. And at x equals 1, I'm getting really, really close. And my slope is 1, but I'm not going to, it's not defined there because it's a sharp corner. And then the last piece that I see is another horizontal line. And so on these horizontal lines, again, a graph, the slope is 0 when the graph is horizontal. So I can say that this m is equal to 0 here. So my slope is 0. On the interval. Well, that's from my x values starting at 1, not including, to my x values going to infinity. So my y value is my derivative on the derivative piece, graphing the derivative function. So at x equals 1, getting close on the right-hand side, I have a limit of 0. And this is always 0. So it kind of takes a little while and a little practice of doing this. And it's thinking again, what's going on when we're finding the derivative. The derivative is the slope. And so if I'm trying to graph the derivative function, I have the same x values and I need to look at my original function and at that x value, what is that slope? And the point's going to be x, f prime of x. So points on the graph of f of x are in the form same x value as our original function, but the y value is what that slope is at that point. Let's see if you guys have any questions. Okay, so again, this one wasn't too bad because if you looked at our original function, notice that those are all lines in there. Notice that that's a piecewise function, right? Because basically this function f of x, they have different equations for different pieces of our function, right? So in this case, I'd have one equation for the horizontal line. I'd have one equation from -2 to 0, that line. I'd have one equation from 0 to 1, and then I'd have one equation from 1 to infinity. And again, this example we just did, it was a little simpler because all these pieces were equations of lines, and there was no curve to them. No, the slope was always constant. So let's look at another example where that might not be as simple, but we can do it. And again, practice is always helpful. Okay, so here's another example where we're given the graph of f of x and we want to graph the derivative function. Let me just warn you really quick, when you're doing your homework on My Math Lab, I noticed this was a problem a couple of semesters with students, and I actually didn't realize it at first too. But when you're looking at your homework on My Math Lab for this section, make sure that your reading is, are you looking at the function of f of x, or are you looking at the function of f prime of x? Because there's a difference, and that will help you when you're doing the homework so that you're not getting it wrong. Okay, so again, we want to graph the derivative function. And so in this piece, the easiest way is looking at, first of all, the lines that are in here. And so I notice until I get to from -infinity to x equals -2, notice that's a line. So all these x values from x is less than -2, or another way to write that is -infinity to -2, have the same slope. F prime of x values. This is a line, it's going to have the same slope anywhere on this line. And so we need to figure out what that slope of that line is. I know that f prime of x is less than 0. That's also going to be helpful for us to notice when is our function less than 0 or increasing, and where is it decreasing. So notice when our function is decreasing on our original graph, f prime of x is less than 0. Our y values are going to be below the x-axis. And if I look at this, as I go down 1 unit, I'm running over 1 unit. Go down 1 unit, run over 1 unit. So my slope on the interval from -infinity to -2, I have f prime of x is down 1, so -1 over 1 is -1. So for graphing the derivative function from -infinity to -2, I have a y value of -1. -infinity to -2, I have a y value of -1. So recall, if we had jumps in our graph, then it was not differentiable there. So x equals -2 does not, the derivative does not exist. But there's other values where it doesn't exist either. So there's a jump in our graph also when x equals 2. So where our derivative doesn't exist, we're going to have open circles there. Let's go to all values of x for the derivative function from 2 to infinity before we look at the piece in between. Notice that that piece is an increasing function. That means my derivative is going to be bigger than 0 here. So for all x values from x equals 2 to infinity, I know that f prime of x is increasing, or I'm sorry, f prime of x is not necessarily increasing. I know f prime of x is greater than 0 because the function f of x is increasing. And in this case, I need to figure out what that is. And so notice if I run over 1, I'm actually rising 2 to get to the next point. That's whole. And so my slope is rise 2, run 1. My slope in this case is 2. So starting when x is 2, my y value is 2. But it's not defined at x equals 2, so I have an open circle there. And I have a horizontal line. My y values are always going to be the same. Okay, so let's look at that middle piece between -2 and 2. So looking at that graph, I know a couple of different things. Well, from -2 to 2, notice that if I'm looking at this, this is pretty much strictly increasing. I level out a little bit right here at x equals 0, and then I increase again. So I know that in this case, f prime of x is bigger than 0 on the interval between -2 and 2. So my y values in here are going to be bigger than 0. So this is where we're going to have a general sketch, and we should have about the same idea. So we want to figure out what is the slope. And so let's look at what's the slope about right here. And so let's just take a little increment of this and estimate what the slope is here. To me, it looks like I'm rising 1 and about going over 1. So when f prime of 2, or maybe not 2, negative 1.99, that looks like we have a slope of, let me just see what this is going. So yeah, maybe it's actually like a negative, because this is actually negative 1.5. So negative 1.5, to 0.5. That looks like a slope of 1. So from 2, -2, I'm going to start with 1. It looks like I have a slope of 1. But then notice that it starts to actually, the slope is decreasing. Notice that the slope in here is not as big. And so in here, notice that that slope in here is not that great. So maybe we're going from, I don't know, here we're running over 1 and we're only rising a half. So to me, that looks about a slope of 1/2. But this is constantly changing. And so notice that we're going downwards. So this is going to be coming downwards. My slope is above the x-axis because it's positive, but the slope is not as increasing as fast. And then notice here, it kind of levels out for a little bit. And so here, we're actually going to come below, or not below, but we're going to come below and kind of hit that y-axis, 0. Our slope is about 0 there. But then we rise again, but we're not rising as fast as we were over here. I mean, we were rising faster. So notice if I like run over, let's say 0.75, and I'm rising maybe a quarter. So maybe going up. That's like 3. So I'm just going to say we're kind of increasing. What about this? To me, 3 kind of seems too big. So if we run over 1, that's 0.25. It's more like it. But anyways, we're coming up, and let's see what's happening here, right here at this value. And so if we look at the slope here, let's just see what that slope would be if that existed. And so if I do this, if I run over 1, I'm going up about 1.5. So it's about 1.5, I would say, when we hit x equals 2. And it's increasing steeper. I don't know, something like that. And you're going to get the general, hopefully general idea. So it definitely is harder when the function, the original function, has curvature to it and is not a line, but you get a general idea. Pause and see if you guys have questions. Okay, let's look at one more example. This time we're given the graph again of f of x, but we're just answering questions about the derivative at particular values. And so the first one wants us to figure out what is f prime of 5. So basically, we're looking at what is the slope of the tangent line at x equals 5. Well, the slope of the tangent line, because this is a line, is also going to be the same line as what's right there. And so I want to find the slope there. And so if we choose 2 points on our tangent line and look at rise over run, we could put it in here and we could solve it algebraically, but I can look at the graph and kind of move along and see what it is. And so here I am decreasing 1. So -1 when I run over 1 in the positive direction. And so my slope of the line exactly at x equals 5 on that function f of x is -1. So f prime of 5 equals -1. So f prime of 0. So we want to look at when x is 0, and we want to see what's happening at the graph there. I notice when x is 0, my graph has like a maximum point there. And so the slope of my tangent line, that would be a slope of a horizontal line. And I know the slope of a horizontal line, is 0. So this should be f prime of 0, and it is equal to 0. And the last one, f prime of 1. So look at what's happening. X is 1. So this is going to be a little harder than the other two because there's a curve here. And so we're looking at x is 1, sorry. And looking at what's happening. So let's try to draw a tangent line. Let's see if I can do this with this. And so if I look at that and I draw my tangent line at that particular value, and then I want to find the slope of that line. And so this is what we were kind of doing at the beginning with that one example. the beginning of class. So here's a point on my tangent line. So that is about point at 2, 1. And then we want to find another point on our line. How about this one? Looks like it's going through. And we're just estimating. So this is -1, 3. So I can do it algebraically, or I can think, okay, from this point here to this point here, let's see how far am I falling. I'm falling a distance of 2. 3 minus 1 is 2. And then I'm running over 1, 2, 3. 3. So if I had done -1 minus 2, oops, I'm sorry, one of them was falling, so that should have been -2. If I had done this, it would have been -1 minus 2, which is -3. So I get -2/3. So f prime of 1 is equal to -2/3. Okay, so looking at the graph, you should be able to find the derivative at particular values. So what you're going to try to do, if it's a curvature, you're going to try to figure out, okay, what would the tangent line look at that, like at that value? And then find the slope of that tangent line. Okay, so we just finished chapter 3. So not this weekend, but next weekend, you're going to have a test over chapter 3 on My Math Lab. And so the tests on My Math Lab are a little different than the tests that you're going to take during a Zoom session. So you have 3 tests for a Zoom session. Those will be 2 tests during the semester, and then the final exam, which is cumulative. But after each chapter that we finish on My Math Lab, the following week, once you've finished all the homework and you're able to turn it in, then the following weekend, I'll give you 3 days to take the end of the chapter My Math Lab test. This is something that you can't get back in and do late, so you want to make sure that you get the test done. It's not this weekend, but again, following weekend. You'll have a couple chances to do it. So if you take it and you don't like your score, then you can get back in and retake it within those 3 days. And if that score is higher, then you're going to get that score on it. You're also going to be writing up the solutions, like you've been writing up the solutions to your homework. You're going to be writing up the solutions to the end of the chapter, My Math Lab test. And I'll have an assignment in Canvas saying, upload your written work for that end of the chapter test. And so you're going to upload that by the end of the weekend. And you're only uploading, if you take it more than once, you're only uploading the test that you have the highest score with. So just so you have that on your radar that that's coming up, I wanted to share that with you.